Hi guys, this is Mrs. Allison. Today we are going to talk about adding and subtracting rational expressions. So just as a review, a rational expression is something where there is a polynomial in the numerator and denominator, which means we're going to be adding and subtracting fractions. So before we get started, let's go back to when we first started learning about adding and subtracting fractions, like 4th, 5th grade. And let's talk about what it means to add fractions. Well, what do we need to do? So if I have something like 1/2 plus 1/3, can I add them as they are? No. What do I need in order to be able to add fractions? Right? I need a common denominator. So what does that look like to have a common denominator? Well, I'm going to start by looking to see if they have anything in common, meaning any factors together in common. So the factors of 2 are 2 and 1. The factors of 3 and 3 are 3 and 1. So other than 1, there's nothing in common between 2 and 3. So to be able to find a common denominator, I'm going to have to start to look at multiples of 2 that are the same as the multiples of 3. So if I don't have a common factor that goes into both of them that I can simplify, then I'm going to have to look for common multiples. Okay, so let's go with the idea of a common multiple since I don't have any common factors. And if I look at this, I see common common multiples to be 6. Okay, so what does that mean? Well, it means that both denominators need to be 6, but in order to make a denominator 6, I need to multiply the first fraction. Well, I can't remember multiply the first fraction, just the bottom. I need to multiply both the top and the bottom. That's not what that problem says at all. Let's try that again. I need to multiply both the top and the bottom by the number that's going to make it be the common denominator. So I'm going to multiply 1/2 by 3 over 3 because then I'm not really changing the problem any. 3 over 3 is really just multiplying by 1. Okay, so when I look at the plus 1/3, what do I need to multiply that fraction by? Well, I need to multiply it by 2 over 2, okay, which is also 1. It's a different one than the other one. That's okay. It's allowing me to get my common denominators. So I would get 3 over 6 plus 2 over 6. And now I can add them. And remember, when I add, we don't add the denominator. We just add the numerators together. So I get 5/6. Okay. That should feel pretty good because we're going to translate that to variables in just a moment, or to regular polynomials. So let's look at another example of what it looks like when maybe we do have a common factor. Okay, so for example, if we look at 1/6 minus 2/15, I'm going to look to see if there's any common factors between these two. Meaning, can I rewrite 1/6? Well, what if I rewrite 1/6 as 1 over 3 times 2? Do you agree that that says the same thing as 1/6? And if I rewrite 15, not sure why this number is getting so big, as 3 times 5, do you see how they share that 3 in common? Do you know what that means? It means we don't have to worry about the 3. The 3 is already a part of the common denominator. What's not a part of the common denominator is the 2 from this first fraction and the 5 from the second fraction. So really, when it comes time to think about what I'm going to multiply by, I'm going to multiply this first fraction by 5 and this 5 over 5 and the second fraction by 2 over 2. Why? Well, because then my common denominator will be 3 times 2 times 5 on both of them, or 30. Okay, so if I look at this, I would get 5 over 30 minus 4 over 30. And when I combine these two, I get 1/30. Okay, does that feel pretty straightforward? So what if there are variables in the denominator? Well, the process is still going to be the same. We are still going to be looking for the least common denominator, the LCD, to be able to find, or to be able to add or subtract these fractions. Now, how do I find the least common denominator when there's variables? Most of the time, we're going to look at the factors. Sometimes these factors are going to be pretty straightforward to see. Sometimes they're not. So let's look at a pretty easy couple of examples and see what that looks like. So for example, if I have 1 over x plus 1 over 2, it's pretty obvious that there is not anything in common. X is as factored as it can be, 2 is as factored as it can be, and they don't share a common factor. So my least common denominator is going to be the smallest multiple of both of them. And so my least common denominator for this particular problem is, I'm going to just abbreviate it LCD, is going to be 2x. Okay, so then from this first fraction 1 over x, what's missing? Well, I'm missing a 2 over 2. And from my second fraction of 1/2, what's missing? An x over x. Well, I'm not changing the problem any. I'm still just multiplying everything by 1. It just now is going to look different. So we get 2 over 2x plus x over 2x. And now that the denominators are the same, I can just add the numerators together. So I get 2 plus x over 2x. Okay, how'd you do? Great. So let's look at a subtraction problem. If I look at 1 over x minus 3 over x squared, do they have common factors? The answer is yes, they have common factors. I could rewrite this, and we probably wouldn't do this, but I can rewrite 1 over x is 1 over x minus 3 over x squared is x times x. So for my first fraction, am I missing anything in the denominator? Well, sure, I'm missing that extra times x. So to get that times x, I need to multiply. The only way we can find common denominators is by multiplying. So I'm going to multiply both the top and the bottom by x, and then my denominators will be the same. So we get x over x squared. Oops, that doesn't say plus. It says minus 3 over x squared. And then when I do my subtraction, x and 3 are not like terms, so the most I can say is x minus 3 over x squared. Okay, so let's try some that are a little more complicated. Here we go. Let's look at this first one. It says 5 over x plus 2 minus x over x minus 1. Now your first thought might be, well, those are pretty close, x plus 2 and x minus 1. What if I just add 3 to both sides? What if I just add 3 to both of these fractions? If I'm adding by 1, because 3 over 3 is 1, if I'm adding 1 to something, does it change the number? It sure does. So I can't add 3 each time. I can't do that. So the only thing I can do to get a common denominator is multiply. And since this doesn't factor, x plus 2 does not factor, x minus 1 does not factor, then I'm going to look for the smallest multiple of each of them. Well, in this case, my smallest multiple, my least common denominator in this one, is going to be when I multiply both of them together. Okay, so if my least common denominator is those two multiplied together, then the question you want to ask yourself is, okay, what is this first fraction missing? Meaning, what do I need to multiply both the top and the bottom by so that it has a common denominator like we're looking for? Well, I need to multiply this one by x minus 1 over x minus 1. If I multiply by 1, am I changing the problem any? I'm not changing the problem any. So now I can go back and I can add to it. Oops, it's subtraction again. I can subtract x over x minus 1. But what do I need to multiply this fraction by? What's missing from the denominator? That's right, x plus 2. So I need to multiply both top and the bottom by x plus 2 over x plus 2. Okay, I would like you to put a star by this problem if you're taking notes, because this subtraction sign becomes very important here in this next step. Okay, now I'm going to combine like terms, and in the top, I am going to go and multiply the numerator together. So I would get 5x minus 5. In the denominator, I'm not going to do that. I'm going to leave the denominator alone, minus, and again, I'm going to multiply the top, so we get x squared plus 2x if I look at multiplying those two. And again, I'm going to leave the denominator alone. I think it's easier to leave the denominator in its factored form. You can multiply it, it's just easier to leave it. Now, here is where this negative comes into play, and this is where it's important. When I go to combine these two fractions, I want to subtract them. What do I need to remember to do with this negative? Remember, I'm subtracting the entire second fraction. So that negative sign needs to be distributed to both terms in the numerator so that I'm actually subtracting all of it. Okay, so my numerator becomes 5x minus 5 minus x squared minus 2x over this factored form of x plus 2x minus 1. Now I can combine like terms, so we get negative x squared minus 2x minus 5 when I combine like terms over x plus 2 and x minus 1. Now, if I could, I would factor the top, but what I notice is there's nothing that's going to multiply to a 5 and add to a 2. So I don't really have to worry about factoring this particular one. So this would be, or this is, my answer. Now, sometimes the problem will ask you to leave your answer in its most factored form. That's this answer. Notice I didn't distribute the bottom. I didn't FOIL it out. I left it alone. Leave it in its factored form. So this would be the answer. Okay, if you're feeling brave, try the next example on your own. Hit pause and try it. All right, so let's look at this example. See how you did if you tried it on your own. Okay, I don't really know. I know I can't combine these because they are not the same at the moment, and I'm subtracting again. I know I can't combine them. So I actually think this problem was meant to be a plus, so I'm actually going to change that to a plus. That is unfortunate. Let's try that again. Okay. Regardless, I still can't combine them. I can't add them together because they don't have common denominators. So the only way I'm going to know if they have common denominators is if I go through and factor both of the denominators as much as possible. Well, this first fraction, that's going to leave me with an x plus 2 and x minus 2 plus x over x plus 2. Okay, so looking at my denominators now that they're factored, do they already have something in common? Yes, they both have an x plus 2. So what is it that I'm missing from this second fraction in the denominator that this first fraction has? Well, I'm missing an x minus 2. So to find a common denominator here, I just need to multiply both the top and the bottom by x minus 2. Okay, so let's go through and do that. Nothing has changed on this first fraction, and again, I'm going to leave it in its factored form. And I'm going to add to it. This time I am going to distribute my x into my x and my minus 2. So I get x squared minus 2x over, and again, I'm going to leave it in its factored form, x plus 2x minus 2. Now I can combine like terms, and in doing so, I get x squared minus x over x plus 2, x minus 2. Now, this is an acceptable answer. However, what you should notice is that I can factor the top. And while it may not actually help me in this problem, I'm still going to go through and look at what it looks like factored. X squared minus x is equivalent to x times x minus 1. And then this has an x plus 2, and this has an x minus 2. Now, if I had a common factor in the numerator and denominator, I would cancel it out. I do not, but leaving it in its factored form makes it really easy for me to see that there is no common factor that can be factored. How'd you do? Okay, try the next example. Hit pause, try the next example and see how you do. Okay, looking at this next problem, it is a subtraction sign again, so let's go ahead and factor everything in the denominator. You can certainly factor the numerator too if you feel like it's going to help you. So this gives me x plus 2 over x times x minus 2 minus x plus 2 in the top. And one of the most common ways people tend to forget to factor is using the greatest common factor. So here I can take a 2 out and it leaves me with an x minus 2. The reason this is important is I can start to see what my common denominator, or what they already have in common. They both already have an x minus 2. So if I were to look at my least common denominator here, they both have an x minus 2, so that's a part of it, although I don't have to multiply that by either side. The fraction on the left has an x. The fraction on the right has a 2. So my least common denominator would be 2x times x minus 2. Okay, so then what is missing from this first fraction? If I look at my first fraction, which is x plus 2 over x times x minus 2, what am I missing from this fraction? Well, I'm missing the times 2. Okay, and then if I look at my second fraction, which was x plus 2 over 2 times x minus 2, weird x minus 2, what am I missing? Well, I'm missing the x. So I'm going to multiply top and bottom by x. Okay, well, let's simplify that now. In this left-hand fraction, I'm going to have 2x plus 4 over 2x times x minus 2. Notice I'm still not multiplying the bottom. I am multiplying the top because I may need to combine it with the next fraction. And if I multiply this next one, I get x squared plus 2x over 2x times x minus 2. Now that my denominators are the same, I can actually combine my fractions, but this is one of those with that negative that's going to need to be distributed. So let's look at what that looks like. We'd have 2x plus 4 minus x squared minus 2x over 2x times x minus 2. Simplifying, I'm going to get negative x squared plus 4 over 2x times x minus 2. Okay, I am going to do something real quick. Okay, I ran out of room, so I just moved that problem to another slide. Now, this answer is actually really good. You have done a good job adding it, but what I look at when I see this is I see that there's actually a few more steps that could be taken. And actually we could have done it, well, let's see. If I go here, I notice that in the top, I could have taken out a negative 1. Doing that would have left me with x squared minus 4. Do you agree with that? The reason I notice that is because I'm always looking to see if there's a way I can simplify top and bottom. And x squared minus 4 is the difference of 2 squares. Whereas negative x squared plus 4 is not, as how it's written. So if I pull out that negative 1, what do you notice? I have common factors here. I can get rid of the x minus 2 and the x minus 2, and it leaves me with negative 1 times x plus 2 over 2x. Okay, now this is one of those questions that on an SAT, ACT type question, you could see this answer several different ways. And actually, you probably wouldn't see it this way. You may see it as negative x minus 2, meaning they've redistributed the negative back in, over 2x. You may see it that way. You may even see it as negative 2 minus x over 2x. Who knows? But one of these possible answers is the answer we're looking for, is the most simplified. This was a great start, but we just didn't finish factoring the top to see if anything would cancel. Okay, try this next problem. Hit pause, try it, come back, and see how you do. All right, hopefully you had a chance to try this. What we're going to look at now is we're going to look at factoring this. So the first thing I'm going to do is I actually am not going to factor the top unless I think there's something in common between the bottom, x plus 8. Oh, there actually is. Huh. Okay, we're going to look at this two different ways. If you happen to factor the top, we'd get x plus 8, that's a funny 8, x plus 8, not much better, times x plus 4 over x plus 8, x minus 5. This will simplify it just a lot. The reason I said we could do it this way, and I didn't notice this at first, is these x plus 8s cancel. And it's okay to do that. So then the problem becomes x plus 4 over x minus 5 plus 1 over x minus 5. Well, that becomes a lot simpler of a problem because my denominators here are now the exact same, which I wasn't actually expecting when I picked this problem, but I kind of like it. And if I combine these two, I get x plus 4 plus 1, which gives me x plus 5 over x minus 5. And this is as simplified as that gets. Now, let's say you didn't notice that, because that was not my intention on this problem. Let's say you didn't notice that, okay? Now let's go and draw a line in just so we can visually do this problem a little bit different. Okay, using the same problem, let's do this. Let's paste a problem in there. Same problem. Okay. Looking at this problem again, let's say maybe that you didn't notice that those were the same, and you went through and you only factored the denominator. So you did x squared plus 12x plus 32 over x plus 8x minus 5. Well, the factoring won't be any different in the denominator. So then what you should say to yourself is, okay, what is my common denominator? Well, they both have an x minus 5, and what's missing is the x plus 8. So from the second fraction, I need to multiply both top and bottom by x plus 8 over x plus 8. Okay, so if you went and did that, you would have x squared plus 12x plus 32 over x plus 8x minus 5 plus, distributing, we get x plus 8 over x plus 8x minus 5. And then combining like terms in the numerator, because my denominators are now the same, combining like terms in my numerator, I get x squared plus 13x plus 40 over x plus 8x minus 5. Hopefully then you notice that both of these can factor. The denominator is already factored, but the numerator can still factor. And I can factor that to be x plus 8x plus 5 over x plus 8, x plus 8 times x minus 5. And then these two cancel out. And so my final answer would be x plus 5 over x minus 5. So you can see there's several different ways we could get the same answer, kind of depending on what you saw. But know that we still need to factor the denominator to see if they have anything in common. It just so happened that what they had in common also was in common with the numerator of one of them. I'm sorry, what they didn't have in common was in common with the numerator. Made it a little bit easier in this first method, which I actually didn't see when I wrote that problem down. Okay, let's move on to the idea of complex fractions. Okay, if you recall, we've talked about complex fractions before, and a complex fraction is really just a fraction with fractions in the numerator the numerator and or the denominator. It could be in both, it could be in just one. But anytime there's fractions within fractions, denominator, it's called a complex fraction. Okay. There are two methods that we can use to solve complex fractions. The first one is the one I like the best. It deals with finding the least common denominator for the whole thing. Not just one part, but the whole thing. Okay? So, if we look at this fraction, the big fraction, we have 2 over x, x over 4, x plus 1 over x. If I look for a common denominator from all three of these fractions that are in the big fraction, what would my common denominator be? Well, my common denominator in this case would be 4x. Okay, so method 1 is going to find the least common denominator and multiply by only the least common denominator. And it's going to look a little different. Okay, so we're going to take this fraction, which is 2 over x plus x over 4 over x plus 1 over 4. That's not actually over 4. That's supposed to be over x, sorry. Over x. Okay, and we're going to multiply both the top and the bottom by 4x over 4x. Now, what that really means we're multiplying by is 4x over 1 over 4x over 1. Now watch what this looks like. It's initially going to look a little bit more complicated. Multiplying this 4x by everything in the numerator is going to give me 8x over x plus 4x squared over 4 over 4x squared plus 4x over x. Now you may say, why did we just do that? Because that does not look any easier. It doesn't look like we're any closer to answering the question. So let's go back and see what happens. If I have 8x over x, can that reduce? Sure. That can become 8. And what about if I have 4x squared over 4? That can reduce to just be x squared. Now let's look at the denominator. If we look at the denominator here, 4x squared plus 4x over x, if you notice that x goes into both of them, great, because it does. Or if you need to factor out an x, that works as well. So let me show you the factoring out step. If we factor that, I could pull out an x and it would leave me with 4x plus 4 over x. And then these x's would cancel out, which is going to leave me with a final answer for this whole thing of 8 plus x squared over 4x plus 4. Okay, so that's method 1. That's the method I like the best. That doesn't mean that has to be the one you like. I wish I had a little bit more room here, so let's see if I can create some. Let's look at method 2. Another way that we could do the same problem is to use the idea of dividing fractions. When I have a fraction divided by a fraction, remember to divide two fractions, we multiply by the reciprocal. Well, one of the mnemonic devices we use is to say that we copy dot flop. So method 2 deals with the numerator dealing with the numerator and the denominator separately, meaning we're not looking at it as one whole fraction together. We're looking at it as two different parts. The numerator is one part, the denominator is one part. Wow, that's messy. And then we would go through the idea of copy dot flop. Okay, so here's what that looks like. First thing I would do is look at only the numerator, the 2 over x plus the x over 4. And I would say, okay, if those are my fractions, what do I need to multiply each of them by to get a common denominator? Well, I would need to multiply the 2 over x by 4 over 4 and the x over 4 by x over x, so that their common denominator could be 4x. And so simplifying those, I would get 8 over 4x plus x squared over 4x. And then when I combine those like terms, we'll come back to that in just a second. The denominator, however, is actually just one fraction, so we're actually in a good place. So combining the numerator, I would get 8 plus x squared over 4x. And my denominator, because it was just one fraction, meant I didn't actually have to deal with it. It is what it is. But now I have a fraction divided by a fraction. One ugly fraction divided by another ugly fraction. So I am going to multiply by the reciprocal of that second fraction. Meaning I'm going to go through the process of copy. So I'm going to copy my first fraction. I'm going to put a dot to represent multiplication. And I'm going to flop my second fraction, meaning I'm going to use the reciprocal. Okay. And now it becomes an idea of multiplying rational expressions. Well, I happen to notice that there's an x in the numerator and denominator, so I'm going to get rid of that. And then when I multiply straight across, we get 8 plus x squared times 1, which is just 8 plus x squared, over 4 times x plus 1. And you can either multiply those or you can leave it. And what you should notice now is that these two are the same. So it's really up to you as to which method you prefer, method 1 or method 2. I don't care. I will probably tend to gravitate towards the idea of just getting rid of fractions as much as or as quickly as possible. So I tend to go with method 1. All right. We will see you in the next video.